Hi everyone, in this video we'll be taking a look at side-angle-side similarity. Here's the FLT. Given two triangles, I will be able to tell whether or not they are similar using the SAS similarity theorem. In the past videos, we've talked about angle-angle similarity as well as side-side-side similarity. Today we'll be taking a look at side-angle-side similarity. The side-angle-side or SAS similarity theorem states the following. If two sides of one triangle are proportional to the corresponding sides of another triangle, and their included angles are congruent, then the two triangles are similar. So we need two pairs of corresponding sides to be proportional, and the corresponding angles in between need to be congruent. So here I have triangles ABC and DEF. Let's look at two pairs of corresponding sides. The first pair is side AB and side DE. The second pair is side BC and side EF. And then we have the angle in between, angle B and angle E. If the ratios of these two pairs of corresponding sides are equal to each other, and the included angles are congruent to each other, this is enough information to tell us that triangle ABC is similar to triangle DEF by using the SAS similarity theorem. So here's our first example for this lesson. Are the triangles similar? We have two triangles, triangles LMN and QRS. So we're going to take a look at the ratios of corresponding sides, as well as the included angle. So our first pair of corresponding sides is side LM and side QR. So let me write the ratio out. Remember, we want the second triangle first, or that's how I prefer. So side QR over side LM. This is equal to 18 over 12, which simplifies to 3 over 2. And we also have another pair of corresponding sides, sides MN and RS. So let's find that ratio. So the ratio is side RS over side MN. That's 21 over 14, which also simplifies to 3 over 2. Since the ratios are equal to each other, we know that we've satisfied conditions for the first part of the theorem. Now let's take a look at the included angle between the two pairs of corresponding sides. So the included angles are angles M and R. Notice how they are marked as congruent. So we know that the included angles are congruent to each other. So let me write that down. Angle M is congruent to angle R. And this is enough information to tell us that the two triangles are similar by using the SAS similarity theorem. So triangle LMN is similar to triangle QRS by the SAS, so side-angle-side similarity theorem. So here, we first found two ratios of two different pairs of corresponding sides. We noticed that the ratios are equal to each other. Then we focused on the angles in between. Because those were given as congruent, we had enough information to tell that the two triangles are similar by using the idea of side-angle-side similarity. Here's example 2. Are these two triangles similar? Notice how the triangles are facing in different directions, but we can still find corresponding sides. In this diagram, side BC corresponds to side GH. So let me write out the ratio. We have side GH over side BC. That's going to be 3 over 6, which simplifies to 1/2. 1 over 2. We're given another pair of corresponding sides, side CA and side HF. So let's set up a ratio for this pair. Side HF over side CA equals 5 over 10, which also simplifies to 1 over 2. The ratios are equal to each other, so we've satisfied the first part of the SAS similarity theorem. In the diagram, we're given that angles F and A are congruent to each other, but these are actually not the included angles. The included angles would be angles C and H, but we're not given any information for those. We don't know if they're actually congruent. So we're not given information on whether or not the included angles are congruent. So unfortunately, we do not have enough information to show that the triangles are similar. They could be similar, they honestly look similar, but they might not be because they don't satisfy the conditions of the SAS similarity theorem. So even if you're given that two angles are congruent to each other, make sure they're the included angles. Otherwise, we can't use this theorem. For example 3, let's take a look at how to fill out a 2-column proof to prove that these two triangles are similar. Notice in this diagram, side KL corresponds to side ML. So let's write out the ratio for this pair of corresponding sides. Side ML over KL equals 10 over 5, which is 2. And side JL corresponds to side NL. These are the longer sides. So we set up a ratio, side NL over side JL equals 14 over 7, which also equals 2. So for our first statement, we can write that the two ratios are equal to each other. So this tells us that the sides are proportional, well, at least the two sides. And this is given to us in the diagram. We also notice a pair of vertical angles right here. So the included angles are actually vertical angles. And we know that vertical angles are congruent to each other. So angle JLK is congruent to angle NLM. And the reason behind this is because vertical angles are congruent to each other. So in this case, we had two pairs of corresponding sides, and the included angles are congruent to each other because they're vertical angles. So we have enough information to show that triangle JLK is similar to triangle NLM using the side angle side similarity theorem. So our reason here would be SAS similarity. So in this example, we used a 2-column proof to show that the two triangles are similar to each other using the SAS similarity theorem. Alright, so let's take a look at one more example. We're going to prove that these triangles are similar. Notice how we have a smaller triangle within a larger triangle. We're going to prove that triangle CST, the smaller triangle, is similar to triangle CDE. We're missing a few side lengths right here. For example, we're missing sides CT and SD. We're going to ignore finding side SD, but we do need to find the length of side CT. How can we find that missing side length? Well, we're given that side CE, the large side, is 39, and we subtract 26 to get the missing segment as 13. And please let me know if you have any questions on how I found that side length. The overlapping triangles might look a little confusing, so I split the triangles up into two. So I have the smaller triangle, triangle CST, and the larger triangle, triangle CDE. Now let's prove that these two triangles are similar to each other. So let's go ahead and find some pairs of corresponding sides. So notice on the overlapping triangle, side CT corresponds to side CE. Side CT corresponds to side CE. So let me write that out as a ratio. We have CE over CT, which is 39 over 13. This simplifies to 3. We're given another pair of corresponding sides. Sides CS and CD. These two sides right here. So let's set up another ratio. Side CD over side CS equals 24 over 8, which also simplifies to 3. So we know that these two ratios of corresponding sides are equal to each other because they both equal 3. And for the reason, although there was a lot of math on our end involved, it was still given to us. Now let's look at the included angle. The included angle is right here, this angle C. For both triangles, they share the angle C, so that means the angle SCT of the smaller triangle is congruent to angle DCE of the larger triangle. I'm basically just saying that angle C is congruent to angle C, and this is using the reflexive property, which we used during angle-angle similarity examples as well. So now we have enough information to show that triangle CST is similar to triangle CDE using the side-angle-side similarity theorem, so SAS similarity. So whenever you see overlapped triangles, you can always break the triangles apart if it makes it easier for you to see. So here's a quick review for today. The side-angle-side similarity theorem states the following. If two sides of one triangle are proportional to the corresponding sides of another triangle, and their included angles are congruent, then the two triangles are similar to each other. So today we use this idea of the SAS similarity theorem to show whether or not triangles are similar. Awesome job today, and please remember to submit your notes on Canvas.